Hello, Precalc. I have put together here some more examples for Chapter 8, Section 1. Now, I'm recording this video after we have already done Chapter 8, Section 2, which is graphing the curves, or graphing the functions sine and cosine. But I had felt that I think we had discussed, or I had felt that you guys wanted more practice. And so then I had created a new work packet called Chapter or 8.2 Work Packet 2. So what I have here is more examples on 8.1 material that will help you do 8.2 Work Packet 2. Hopefully that makes sense. So I'm just going to go through these examples. I think I have 4 examples here. And the reason it's starting with example 4 is because I'm considering this a continuation of Chapter 8, Section 1 notes, which the last example in those notes was example 3. Okay, even though we've already done Chapter 8, Section 2. Hopefully you're following all this. So I'm just going to go through 4, I believe it's 4 examples here. Yeah, 2 degrees, 2 in degree form, 2 in radian form. And I'm going to hopefully break down what we do for these simple, and they're called simple because they get more complicated, trig equations, solving simple trig equations. And I think that about recaps it, so I think I'm ready to go into the actual problem here. So the first example for this second set of notes for section 1, chapter 8, is to solve cosine theta is equal to 7 over 15. Again, theta means degrees. We're in degree mode. Whenever we're doing degrees, we can round to 1 decimal place. When we're doing radian, we need to round to 3. And we want to solve this. We want to find what values of theta, when plugged into cosine, give me out 7/15. That decimal value, or the fraction 7 over 15. And there will be a restriction on my solutions, 0 to 360. Okay, that restriction for going from 0 to 360 allows, or not allows, but helps, because if it wasn't for this restriction, we'd have an infinite number of solutions that we could plug in for theta, a number of decimal values, and get 7/15 out. Because, for example, let's say one solution, this isn't true, but let's say one solution was 30 degrees. Well, every time you add 360 to that, 390, add 360 to it again, and every time you add 360 to it, it would be you get to the 7/15 because of coterminal angles. One full cycle around the circle, and you're back to where you were on the unit circle, and you will get the same ratio. Okay, so this restriction reduces the number of solutions we have from an infinite number of solutions to, most cases, 99% of the time, it'll reduce it to 2 solutions. Those 2 solutions will be when cosine gives you positive solutions. The 2 quadrants of the 4 quadrants that give you positive solutions for cosine. Okay, so and as you remember, for cosine, positive solutions are in the first and fourth quadrant. There will be a negative 7/15 in the second quadrant, and there will be a negative 7/15 in the third quadrant that cosine is equal to. But only in the first and fourth are there positive 7/15. Okay, and that's, again, just recapping, going back further, cosine of an angle is equal to the x value over the hypotenuse, and the x value is negative in the second and third quadrant, positive over here. A little bit of a recap. Hopefully that helped and didn't confuse you at all. Solutions in first and fourth quadrant. I do note that there. But before I even note that, I think that maybe I wasn't emphasizing this right here enough. Um, so because we're in degrees, I only did the degree form of these reference angle formulas. And what I did was I just wrote the reference angle formula for each quadrant. They're all there. And the barriers for each quadrant. 0 to 90 is first quadrant, 90 to 180 is second quadrant, 180 to 270 is third quadrant, 270 to 360 is fourth quadrant. So this will be useful, and I want you to use these. Okay, I want you to use these reference angles. Even though some things might be intuitive, I want to see you using these because the process of using these always works, and the intuition doesn't always work depending on the scenario. So we're solving cosine theta is equal to 7/15. To undo a cosine, we do the cosine inverse of both sides. That's what we're trying to do is isolate theta. So we're taking cosine inverse of both sides. Cosine inverse of cosine is just theta. Cosine inverse of cosine theta is just theta. And then we have cosine inverse of 7/15 on the other side. What you'll want to do then is you're going to need to use your graphing calculator. Let me clear that. You're going to need to use your graphing calculator to find the solution for this. So cosine inverse of 7/15, I'm going to make sure I'm in degrees. I am. We'll do cosine inverse 7/15. We're going to get a degree answer of 62.18. 1 decimal place, I round that to 1.2. That 0.18 round to 0.2. This is my first quadrant solution of my two solutions. I just found the first quadrant solution. I know that because the calculator gave me a value that's between 0 and 90. It wasn't a negative value, and it definitely wasn't a value over 360. That is in my range, 0 to 360. So that's a first quadrant solution. That is convenient because our formula for reference angle from a first quadrant solution is alpha is equal to theta. So I want you to always identify the reference angle clearly. It's very convenient that we have a first quadrant solution because our reference angle will be the same as our first quadrant solution. Okay? And just to recap what the reference angle is. So cosine, the way this works is cosine will go through every value, the ratio of cosine, 7/15. Cosine will go through every value between 0 and 1. Okay, it's going to start at 0, it's going to start at 1, sorry, then it'll go to 0 and it's at 90 because the x value is 0, and then it's going to go to 1. That's going to actually go to negative 1, and then it's going to go to 0, and then it's going to go back to 1. Okay, so every value between 0 and 1 is hit in each quadrant, with two quadrants being negative and two quadrants being positive. But the digit value between 0 and 1 is going to be hit in each quadrant. So there's a reference angle in the first quadrant that these formulas allow you to find in each other quadrant that give you the same ratio. What that means is there's a 7/15 in the first quadrant. There will be a negative 7/15 in the second quadrant. There will be a negative 7/15 in the third quadrant, and there will be a positive 7/15 in the fourth quadrant. So the reference angle tells you which angle, if given the first quadrant angle, you can find the angles in the other three quadrants that give you the 7/15 or negative 7/15, depending on whether it's a negative or a positive answer. So the reference angle allows you to find the angle measures in the other quadrants that give you the same decimal value out of that trig function. So that's what this is. This is our reference angle. 62.2 is the angle measure that gives me, when plugged into, approximately 62.2, when plugged into cosine, we get, it'll be approximately 7/15 out. Okay, going back over here. I'm going to try that, 62.2. Now, it's not going to be exact because I'm rounding, right? And I also need to know what the decimal value of 7/15 is. And you can see 4.466 is, because I'm approximating, it's not exact, which would be 0.466666 repeating. Hopefully that makes sense what the reference angle is. And the reason I want that, or I need that reference angle, is I'm going to then look for, it's pretty easy to find the first quadrant solution. To find the fourth quadrant solution is a little bit more work. So let me erase something here. Oh, maybe I can't. There we go. I just decided not to underline my solutions because I summarized the solutions at the end instead. Okay. So I have my so after I found the reference angle, I know this first quadrant solution is up here, but the reference angle won't always be this easy to find. I want to just kind of summarize. I just want to group my two solutions together. So I've decided that I'm going to always put it in quadrant order: quadrant 1 solution, and then quadrant 2, 3, 4, and whichever ones you're looking for. Not all three of those, but or not all four of those, but the ones that you're looking for. So quadrant 1 we have. Quadrant 4 solution, we're going to use this reference angle. That's why I put this up here. And the reference angle formula, we're going to use this reference angle formula. Alpha is equal to 360 minus theta. So if I'm given a fourth quadrant angle, I can do 360 minus that fourth quadrant angle to find the reference angle in the first quadrant. Well, I'm going to do the opposite of that because I have the reference angle, and I'm going to look for what value of theta, when I plug in, do I get the reference angle out. So I'm doing this in reverse. And I'm plugging 62.2 in for alpha. I'm going to make this approximately now because once I put a rounded value in this equation, the whole thing is approximated. And I'm going to solve this for theta. So I'm asking myself, what value of theta gives me 62.6 here? Do that by adding theta to both sides and then subtracting 62.2, or 60.2, and I get 297.8. Okay, so then I'm going to summarize it here at the end one last time. After the reference angle, I have them both listed, and then I'm summarizing thus. All right, just before we continue to the next problem, I just want to double check these answers. So I already did double check the 62.2, but let's just double check that this other answer, 297.8, also gives me something close to 4.66, and it does. Okay, so we got two theta values between 0 and 360 that give me, when plugged into cosine, I get 7/15 out. Okay. Hopefully that makes sense. Yeah, I think that's all I needed to do for that problem. I have another example here, and so let's do this example. I was just trying to think if there's anything else that, I wanted to say about that. I feel like these are a little lower than they should be. Oop, don't want to move all that. I'll move that later. Seems like there's a gap there. Oh, shoot. All right, I'm going to pause this for a minute, and I'll be back in just a minute.